In this video, I'm going to continue with work, energy, and power. And if you look at this question, this is Joint Universities Preliminary Examinations Board. In this question, a question under work, energy, and power is asked at the back. And we can see it here. Question 2A2. State the work energy theorem. State the work energy theorem. I will work on this as a revision of my previous work, and I'm going to show you what is called the work energy theorem. I said it that if a body moves from here to here, and let me shade this part to show that movement has been done from here to here. Now, the distance covered is S, like I said it in my previous video, and this is applied force F. Initial speed of the body is given here, final speed of the body is given here, and we then say that work is equal to Fs. That's the definition of work. Work is equal to Fs. Now, Fs, what is force? Mass times acceleration. Mass times acceleration. Then multiplied by S. From equation of motion, which is a v square is equal to u square plus 2as. From here, let's make A the subject of the formula. V square minus u square is equal to 2as, and v square minus u square over 2s is equal to A. As a result of that, I have m open bracket v square minus u square over 2s multiplied by s. This s will cancel this s, and we have mv square over 2 minus mu square over 2. This is work. If we rewrite this, I'm going to have w is equal to half mv square minus half mu square. Now, it is obvious that half mv square is called kinetic energy. Half mu square is also called kinetic energy. But this is for initial speed and this is for final speed. This means this is final kinetic energy, and I will title it K2. Initial kinetic energy, and I will call it K1. That means work can be expressed in terms of change of kinetic energy. Work can be expressed in terms of change of what? Kinetic energy. So how do we now state? According to this exam, this JUPEB exam, according to this JUPEB exam, this question can only earn you, I think it cannot earn you more than 2 marks, because A1 and A2 together they are 3 marks, so it cannot earn you more than 2 marks. As a result of that, you need to be very careful and state your answer accordingly. We are asked, state the work energy theorem. So, work energy theorem. Work energy theorem. Work energy theorem. State that the work done by what? A force. This force is an external force applied on this body that causes the stance of the body, or that causes the displacement of the body. Let me come again. Work energy theorem states that the work done by what? This force. This force brings about displacement of this body from here to here. So work energy theorem states that the work done by an external force, by an external force, by an external force, can be expressed in form of work done by the force on the body, which is equal to change in kinetic energy of the body. Very simple. It is as simple as that. Write it like that, you will get your 2 marks. But you can always finish it with work is equal to half mv2 square, or let me use v, minus half mu square. You can always finish it like that and you will earn your mark. Alright, now let's move on, because the major one for today is conservation of mechanical energy. Conservation of mechanical energy. Conservation of mechanical energy. Conservation of mechanical energy. At this level of our physics, we still believe that mechanical energy consists of mainly 2 forms of energy. We have the potential energy and we have the kinetic energy. We have already learned that work can be expressed in terms of K2 minus K1. But the potential energy can always be expressed in terms of work as well, which is equal to U1 minus U2. U1 minus U2. If U is my potential energy and U is my potential energy, this is the initial potential energy by a body, of a body. This is the final initial potential energy of the body. So according to conservation of mechanical energy, it states that work is equal to K2 minus K1, which is equal to U1 minus U2. This means that minus K1 minus U1 is equal to minus U2 minus K2. When we multiply this by minus 1, we have K1 plus U1 is equal to K2 plus U2. And this is work. What does this mean in physics? Let's show a diagram for that, for adequate explanation. For adequate explanation. Let's show a diagram for this. If a body, this is the horizontal and this is the vertical. If a body is dropped here, it has not gained any kinetic energy. So it has only potential energy. And let me call this height H1. It means the only potential energy here is mg H1. By the time the body is here, it has H2, but because it has moved from here to here, it means it has a speed and it has a kinetic energy. Because it has a height of H2, it also has potential energy. As a result of that, it has a kinetic energy here, which is half m v square plus mgh2. So the total energy here is this. The total energy here is this. If at the end of the day, the body is now on the ground, no more height, no more height. It has only kinetic energy. It has only what? Kinetic energy. As a result of that, we then have only half mv2 square. To differentiate this speed from this one, let's call this one 1 and let's call this one 2. According to this law, then it means mg h1 is always equal to half mv1 square plus mg h2, which is also equal to half mv2 square. That is the law of conservation of mechanical energy. In words, it states that the total energy possessed by a body remains always constant. That is just it. So thank you for watching my video. This video is directly from Tutopedia Tutorial Center. We are located at Agbo, very close to University of Ibadan. I will implore you to always subscribe to my channel. Please, I'm begging you, subscribe to my channel so that whenever I have my new video, you will be notified. Always remember as well to click on the bell so that when I have my new video, you will be notified. Thank you so much.